yet. Yeah.
Yeah, that's fine. You don't have to. You don't have to be. Everybody, please, can you mute yourself? There is a background noise, and we will have a dedicated session for question and answer. Just bear with us until we get to that point. Can you mute yourself, please? There is that you should see a button, a mic button. Just click it. I think I will be able to do it, but it saves me a lot of time. You don't have to do it for everybody. So you just mute yourself. Okay, let me try the share screen. All right. Let me know if you can see my screen now.
I can see it. How about
Yep, I can see it.
All right, great.
Thank you very much. All right. So you see it in full screen now, Ashraf?
Yeah, I see the screen. Definitely.
And you can hear me good?
Yeah, I can hear you good. How about you, everybody else? Can you hear Dr. Fardo Bhatti? Fardo is the host.
Yep, I can hear both you guys.
All right. Thank you very much, guys.
Thank you.
And welcome
Yes, I can hear.
to our first session. And I am Furdubati, and Ashraf is with me, and I believe Ed and somebody else. I didn't go through
Yeah,
the list.
I am
Fine.
Ashraf Shirani, co-host.
So this is to give you an overview about the course, the outline, and the content. So again, welcome to the class. We have three sessions this semester. I believe all the classes are full, all to the max. So uh, we I will go through again. This is a highlight, and of the class we don't get into details of any of the content, and then we'll get a chance to cover everything as we progress in the course. But this is to go over some of the criteria, some of the expectation, what you will face the challenge, and the time aspect. So we'll try to cover all that, and then where this course fits in the entire MS program, the Master's Analytics program with the university. And we will have a session at the end of the presentation for question and answer. Okay, so these are the parts, and we have some introduction about the course content and how it is structured, the grading, how we will. Now, we will try to be consistent across the different sessions, so we will try to follow the guidelines uh, of the university in the grade. And there are some miscellaneous items that I'll get, and then we get to the question and answer. Okay, since I believe since the last semester, the university has moved to the open educational resource format, which requires no textbooks, so you don't have to buy books. It's not required. Although, from my experience, you will be spending money so as you progress in the course. I don't know. It depends. You can find pretty much every material online these days, but I tend to prefer, art books, paper copies. But for this particular course, you're not required to buy books. So it's open source. Every material will be presented in the website. Each module will have content, all the lecture videos. Uh, if there are any additional resources like web-based articles, um, and sometimes there are conferences sponsored by the university, we will provide links for those as well. Um, so another really important for this class is that you need to regularly check the news section. I think it is the landing page. The first time you log in, it will take you there by default, I believe. And if there are, I typically in my section two announcements, I make two announcements for that module. But sometimes there are more because there are conferences, maybe there are TA sessions. So you're better off checking the announcement regular. Okay, so this is about data, the placement of data in the entire program, the MIS program. And my understanding is that there is sequence, there is prerequisite for every successive courses. So by this time, my expectation is you must have gone through both 610 and 620, um, and this is data 630. This is to show you some visualization about the placement of this course in application real life of data analytics. Usually, you just some kind of discussion, and this is typical in most data analysis or data science projects. Is you do some kind of descriptive to try to understand what happened from the data. If possible, you go to the diagnosis, try to answer why the things that you observe are behaving that way. And then you get a little bit, to the predictive modeling. This is a machine learning type statistical modeling phase where you try to predict from, by creating models and classify or do regression or prediction on unobserved samples, on or unobserved cases. And as you progress, and again, the material we'll cover in 630 will try to address most of, at least the common machine learning or statistical modeling techniques. But there are some advanced topics we won't be able to cover. And then those you will learn in 640. And 630 gets into big data and also prescriptive. Prescriptive, in my opinion, hasn't matured to the point that you can rely on it a lot. But basically, this is you can actually intervene. You learn the data, you do prediction, but not you don't stop at prediction. You also try to prescribe, like by intervening, by taking some action, try to change the course of events. So that's what prescriptive is, but it doesn't always work in that way in real life. The main thing is this course is not heavy on the mathematics. The mathematics is critical, but it's not heavy on the underlying mathematics. This is a hands-on course focusing on the programming. You will do a lot of exercise, a lot of practices. So believe me, if you spend resources by the end of this course, you will feel good about your modeling capability, especially for those of you who have never done programming before. That doesn't mean the underlying mathematics is not important. It is critical. You will have to deal with that at some point in your profession, and then as you progress in the course, you might be exposed to a little more underlying mathematics. But the focus in this course is practicing applying some programming skills to the existing algorithms, to the algorithms implemented in the R package, and be able to create models, test models, tuning it in diagnose. By the way, Ashraf, if you find I missed anything as we go, or if you have any additional things to say, please stay.
Sure, that's great what you said. This particular this specific graphics here in this slide, the top level kind of shows various categories of analytics, starting with more basic and also common ones like diagnostic, descriptive ones, starting with the older ones and simpler ones, describing what the data looks like and what kind of trends might be in there, so on. Then going on to finding why things are happening the way they have been happening. So things like you could test your hypothesis. You may have some hunch or some idea that the sales are decreasing, or a particular in the medical field, a particular ailment is due to certain factors. You could test them based on your data and see whether that hypothesis holds. So going further, you could use, in many cases, using your something we're going to talk about shortly, supervised learning methods, meaning learning from past data that has both the uh, data on independent as well as dependent variables, and then learning from that, building a model, and using that to predict in a data set that does not have data on the dependent variable or the response variable. Prediction is one of the common, or forecasting and predicting is one of the common exercises. And prescription goes beyond that, what to do, recommending various courses of action. So techniques such as simulation, optimization, and a number of others one could use to the alternate paths to, you know, achieving your objectives. So at the bottom of the graphics, you see those courses, 5 courses listed in different arrows. One thing we should point out is that these courses are approximately, they are in that order, of course, 10, 20, 30, 40, and 50, and then also later on the project, but they do not fall into one category or the other strictly. I mean, there's no demarcation whether this course is for predictive analysis or diagnostic analysis. Many of these techniques appear in most courses. For example, descriptive to predictive. So the bottom part, the 5 arrows, are basically in succession of the techniques you learn. For example, 6:30, you are learning some initial and basic fundamental data mining techniques. Then 6:40 is kind of continuation, but more advanced techniques such as support vector machines and others, deep learning. And then 6:50 is about big data analytics. Big data, you guys know that very popular in industry today. Starting with the various V's, this defines the properties of big data: volume, velocity, and variety. So capturing, let's say, for example, data coming in, streaming data coming in at high velocity, how to take advantage of that, how to capture and use it right away, otherwise it becomes kind of stale. So all kind of techniques that are being explored and used, they are in 6:50. So again, even though the top green arrow, the larger one, kind of indicates that, well, there are various levels of analytical techniques in terms of their detail and usage. Our courses cover them all, but not necessarily by those levels. Okay. Thank you, Fardu. Please go ahead.
Okay. Thanks for that. Yeah, the last thing that you said was really critical. That yes, for understanding purposes, there are different phases or different aspects of analytics, like descriptive, diagnostic, and predictive. But typically, what you end up doing is really you have to understand what is in the data, which is mostly through descriptive analysis, to go to the predictive level, and then diagnose always is part of the equation. So these are not distinct phases, but those are a part of the activities that you have to do in any typical data science or data mining project. Going forward, so these are the different areas that we will cover. So this course is modularized into six, including the 6 modules without the project. And the project is in a way the seventh module. We don't call it seventh the module, but there is a 1 week period where you will finalize the project, but you will work on the project throughout. So the first module is kind of introduction, the easy part, about the fundamentals of data mining, how you do data preparation and visualization. So this is, between this week and next week. So that we don't have assignment for this module, but you will be doing 2 exercises. But that is, and then this is critical. It always, and any data scientist will tell you, it is really not the case that you will get to the modeling without dealing with some data preparation and cleaning. I mean, I have never seen a case, at least a real data set, where everything is perfectly the way it is, quite ready for modeling. So you'll be doing some understanding, you'll be doing data cleaning. It depends, the content and how large the data is, how clean it is. But you will be doing some data preparation. So it is this phase, even though for some data scientists it is the boring phase of the data science project. But if you don't prepare your data well, the end result is not good. So visualization is part of that as well. In the course of understanding the data, you have to do some visualization. In R has some nice visualization capabilities that you will see in this module, both in the exercises and some of the tutorial. And in module 2, we move to association rules. Can you guys please mute yourselves? This is background noise. Yeah, I guess I have to do it myself. Yeah, please mute yourself. And association rules is data mining, is a very typical data mining algorithm that you don't have to, estimate any function. You try to identify correlation, basically patterns, and I'm not going to get into, what each analysis will involve. But association rules in module 2, I think there's only 1 week for module 10. There is corresponding assignment for that. And then we move to in module 3. I think it will be 2 weeks. We will learn about regression, both linear and logistic regression, in Bayesian classification. And yeah, you will be doing both exercises and assignments in that one. And then we move to more of like a machine learning type of learning, like supervised classification. The first one of that will be decision tree. So we will cover decision tree in module 4, and then we'll move to neural networks. And then we go to unsupervised classification. A very common unsupervised classification is clustering, and we work on clustering. And then there is advanced topics on your project. Like I said, we will help you form the project groups. I believe in the 3rd week, and there are some milestones you will work on, so you don't have to worry about that waiting until the last week to because most of the material for the project will not be covered in the rest of the course. So this is more like research type of work for you. And one important thing is the material you'll cover in the previous one, or the skills you learned from the previous module will be really useful in the next or in the subsequent modules. And for instance, when you do linear regression or decision tree, the typical task is you clean the data. So by that time, you already have practiced how to prepare data and clean data to do visualization, some inference, or descriptive statistics. And part of that as well is fitting a model, and then doing diagnosis, and testing the performance of the model. That is typical task. So you will see from module to module doing the same thing on different algorithms. So this is really the content. And again, we will go. This course is packed. And when I first started teaching it, I thought it was a lot of material. But given that you only take 1 course for this graduate course a semester, but still you have to spend good amount of time every week to be able to master, or digest the content. Going forward, it is a competency-based UMC course. I think UMC keeps refining its courses, and what it means is graded assignments based on what you know, and not what necessarily by what you do, but not by you know. What it means is, yes, you might know the content, but unless you show us the instructor by actually doing it, explaining your assumption, what you have done, explaining the result, we won't be able to grade you. So for the purpose of the grading, knowing is critical, but it's not sufficient. So you have to perform, you have to show it. I think assignments are fewer in number. I mean, one could argue that's not the case, but the practice exercise is they're not assignment. Those are for you to give you the opportunity to get familiar with the syntax in R and understand the concept by actually playing with the algorithm. The assignment is where it's expected from you to explain all the the modeling, the details of the output and the assumption. Weeks between assignments. I think I've said this. This is basically the information you or the lessons you learn from module to module. You can carry that over. That's it. If you have done validation, so you have learned how to do validation, you still have to do a validation for a different algorithm the next module. So the activities, they support each other. Opportunities to learn software tools. We use R here primarily, exclusively. That doesn't mean R is the only tool, but it's a very popular and powerful package. Uh, there could be some learning curve depending on your familiarity, but we will cover the basics, and then the tutorial, the practice exercise, give you the appropriate algorithms and the relevant syntax for the R pack, the R tool. And R Studio obviously goes with it as a user interface tool. By now, you most likely most of you have seen how R Studio looks like. There is an upcoming tutorial on R on I believe on Friday by TS. And we will get to discuss. We have forums in the class. Please participate. If you have stuck on something, just use the TA forum for question and answer. So that's what competency based basically. Now, this part is I'm told that the university refines the scores continuously updating to reflect what is what data science looks like in the real world. So it works with both industry and government. The companies that listed you see here, Lockheed Martin, MITRE, Booz Allen, and also government agencies, to get feedback how the industry practices data science, what is really useful, what is the trend, and it adjusts this. And then I think most universities do that. It's a good thing because data science is not done in vacuum. When you're done with this course, there's expectation that you can deliver. So, and the program has won a number of awards. It looks like in the 2016, as you can see in the bullets here. So good, so good validation that you chose a good school and a good program. Okay, like I said at the beginning, we have 3 sessions this semester, and I teach 9040 in Ed 9041 and 942 Ashraf. I believe Ed is in the forum as well, and we have TS. John is my TA. Eric for 9041, and then 942 actually two instructor, Fred and Ashraf, and then John also TA for that course. So this is we try to leverage whatever information we can get from one another. We support each other, and then we actually design the course all together. And by all means, please use the TF forum if you have any programming issues. And the TS are there to help you on programming and syntax of your software problems. Yeah, it's likely you get stuck, once in a while you do your exercises and when you work on assignments. So please use the TF forum to do that. Okay. Just a reminder that there is, I believe, it has been posted at least in my class.
Yeah, it's posted in all sections. Yeah.
Okay. And so there is another session. This is just on R and how to do installation on R Studio. The basics, especially for those who have never touched R before, it's a good opportunity to see, how some of the basic functionals are.
Yeah, Jelena is presenting that session on Friday, this Friday.
Right.
Yep.
And we will continue this pattern that from module to module there will be a video session or a WebEx session on the programming aspect of that content for that particular module. Okay, here is the assignment. Like I said, there are 5 assignments, and as you can see the weights for the grading weights, and except in this module, which instead you will be doing two practice exercises. All the other modules will have corresponding assignments, and then we have a group project. That will be the last. I think that's 20% of the total grade. So it's absolutely critical for you to start working on the group project early enough. Like I said, we will put something on the third week for you to select your group and have a discussion. And also every week we have exercises. Those exercises have grades. So you'll earn some points for working on grades, 2 points each for each exercises. But the exercise are really useful. I mean, it shouldn't be even graded. I mean, if you do the exercise, you'll have easier time working on the assignments. And the assignment, obviously, you are expected to write more in depth and explain the result, and also some parameter tuning, explain those concepts. And in any modeling, you make assumption, you have to explain those as well. But the exercise is, there are some questions, but for the most part, for you to get acquainted with the R syntax for that particular algorithm or material for that module. And yeah, the total grade is, again, the group project is really important for you to pick a right data set, something that interests you. And that is part of the reason when we form the group, you get a chance to have a discussion in the class so that you pick a group that has a similar interest on what you want to do. But we will get to the details when we get there in a couple of weeks. Assignment 1, this is pretty much redundant information. So basically, every assignment will reflect on what we cover in that course. So assignment 1 will be association rules because that's what we learn in module module 2. And assignment 2 will be on regression, linear and logistic regression. Assignment 3 on decision trees. And assignment 4, neural networks. And then obviously assignment 5 is on clustering. And the group project is a web-based or text mining. But the domain is not specific. You can pick whatever domain that works for you. And by the way, this course, for instance, decision tree, there is advanced implementation of decision tree, for instance, ensemble trees. Although we don't cover that in this course, you will learn that in 640, but the basics you will cover. You have to go to the advanced, let's say, an ensemble model. You have to also learn the base model or the underlying model that makes the ensemble. So the material that you will learn here can be compared to what you will cover in discussions. Again, you will earn grades for discussion. The initial post, at least in my class, the initial post is worth 1 point, and the response posts are, there's guidelines. I mean, you can follow the direction in the website on the class page, but 0.5 each for response. That means well thought responses. Content matters, but there's another opportunity for you to earn grades. But the most important thing is you learn from reading by reading other courses, and it's really good. I have learned it quite a bit myself by interacting. I tend to get engaged in the discussion forums. I will every week I will post something. So uh, it's a good forum for interactivity, and again the other forums for asking questions, the TAs and things like that. Uh, I think we have three other casual channel, I mean forums as well. If you have any other interest different from what we cover in the course, there is a forum. I forgot the name of it. What cafe? Something what we call it. But yeah, use. So we have multiple forums for questions and discussions.
Yeah, there are two types of forums. I think one is this graded discussion. Then there is another one for Dart groups. So each group has its own separate discussion area. Once you form the groups, please let us know, and we will create your separate discussion space so you can share your documents within that space privately within your group and communicate as well. So there are two different areas under the discussions for this purpose. One is for uh, topics that we are actually using for hands-on work and learning. So actually to share what everybody else knows on those topics. The second set of discussion threads within the second forum is for your group projects. Yeah, I think that's what you're saying, Fardu, probably.
Right. Yeah, I forgot the group project. Yeah, the group. When we form the group project, each group will have a dedicated discussion day. That's where we interact. Well, that's where you discuss project specific materials. And at least in my class, what I also do is I create a lock, a share, basically a place where you can share your documents as well.
Yeah, there's a
So locker, yeah, they call
locker,
it
yeah.
locker. Okay. Grading, if it's not clear by now, so we will follow the guidelines and the university policy. So on time, on task, well written, complete, properly documented is a B, right? You have to go beyond what is expected to earn A, which is above 90%. So we try to list those things that are expected that qualifies you to get the highest grade, which is depth, breadth, uh, do your discussion. I mean, there is all opportunity. Wherever there is grading, there is or wherever there is assessment and grading and exercises and assignments and the project, content matters. The way you discuss materials, the way you explain up with. It's a graduate course, and I'm sure you are most familiar with this kind of thing. I'm just stating the obvious, but needs to be said. So if you want to grade that's not typical, right, or what's not just unexpected, you want to get the highest grade, you have to go beyond what is expected. So find example support. Examples another really. Sometimes you explain things that you can't really get your points across. Use examples, and that helps. And uh, there is some subjectivity because being instructor, I guess you can't avoid that, but we try to be as objective as possible. We use rubric for each assignment. Uh, but yeah, that's the expectation. Some critical
Also,
thinking.
if I may
Yeah,
add, Fardu, yeah,
please.
each assignment comes with rubrics for grading. So I suggest that you guys please look into that. There's a table of rubrics, meaning telling you, well, this topic done this way counts up to this percent of your grade in this assignment, and so on. So rubrics is very important to view and follow as much as possible to get a good grade in each assignment. Okay, so rubrics are one of the things in every assignment. So that makes it a little bit structured grading. Even as Fardu is saying, subjectivity there, but giving those rubrics kind of makes it quite uh, objective as well. Okay, go
Yeah.
ahead, Fardu. Thanks.
Okay, yeah. Just follow the rubric as much as possible. You will not at least there's guideline in the pages for each assignment, but you won't be penalized for adding. Don't just give me volume for the sake of extending the document. But if there's good content, don't be limited by the recommended page. If you have good material, I will read it. We will read it. Okay. The purpose of this slide is so there are different standards, and you will learn about Crispy. Probably you have covered Crispy DM. This is like a de facto standard for. It's a framework. It's not a tool. It is how you approach any machine learning or any statistical or data mining project. Remember, it's not done in vacuum. Data science, you have to have a business problem. You got to understand that. What is expected, from that model that you're building. So the business understanding part is critical. So we will do in every project. In fact, there is a section in your report that you have to provide what is the objective, what is the justification for doing that. You have to always provide that. The next is you have to understand the data. So you go get the data, or whatever appropriate data for the exercises. In the same way that how you would do in the real life is you have to understand the data, explain the variables, clean the data. Well, the cleaning goes after the understanding. So in the understanding phase, you have to do some visualization as well. And then you get to a point where, so you have to maybe deal with some missing variables or some missing values. You might need to impute it or delete it, whatever is appropriate, which we will learn in this module. That's basic about data preparation. And so you make your data ready through that. Maybe you have to create training samples, test sample, validation sample, or if you have a small data, maybe you end up using cross validation. But that is part of the data preparation. Then you go to the modeling phase, depending on one of our algorithm. Now, in this class, for this class context, you will be given the algorithm that you will deal with for that module. Then you fit that module, you tune the parameters, and that is critical. And I emphasize that point all the time. And that's what I do in my real life. Fitting the algorithm is a statement. Everybody does it. You have to tune the parameters. What is a parameter that is gives you the optimal result? And you have to explain in your report when you write the report for that assignment. Explain about the parameters. Some algorithms are parameter intensive that you have to tune multiple parameters. Some are couple or one, but it is an important skill, and that's what you do. We rarely write new algorithms as a data scientist. I don't know. I don't remember, at least after my PhD thesis, I've never done a new algorithm. I play with existing algorithms, but I have to know them to by tuning the parameters. So it's just critical statement. I can't emphasize enough. And you have to write something about that. And part of the modeling is also validating it, how well it is performing, both for supervised and unsupervised learning. For supervised, it's easier because you have a ground truth that you compare the output model with the result, with the test or the validation set. But it has to be done in unsupervised learning clustering as well. So that is part of the modeling. And then in the CRISP DM here, the evaluation is actually separate phase. But most of the time, when you do modeling, you evaluate it, you go back, you iterate, and run the algorithm with modified parameters, and then you evaluate until you get to a point there it's acceptable for your domain. And deployment, we don't deploy in this environment, so your deployment is basically providing that report to your instructor for submission. So for the most part, we try to follow this pattern. It applies from one algorithm to another, and then again, it makes your life easier even in the work environment. So Try to follow it. Uh, Here and there, you might deviate a little bit. That's fine. I mean, if you have already good understanding about the data, maybe you don't have to spend that much time. You can go to the modeling phase. But typically, this is what you would follow in the data mining project. Uh, okay, this is, I guess, a recommendation for success. Uh, Spend as much time, I guess, in the class, in reading. Uh, there are a lot of materials. I mean, for data science and the wave. Sometimes it gets overwhelming. We struggled in the past, how much information you have to provide, but at some point it gets overwhelming. You don't want to just provide a lot. But there are good materials, a lot of materials on YouTube. There are a lot of videos, but we also provide video lectures here. The announcement section is critical. If there are some things that I need your attention on, or on the other structures, we will post in the news section. So please check daily, ideally. Um, would be ideal. And like I said earlier, once in a while there were conferences sponsored by the university, and especially for those who are local that can attend in person. If those information are provided to us, we will post them and ask questions and question and question. We have a dedicated TA for each session, so and I know you will have I know it's just part of life in data science. Sometimes you get error. Sometimes R doesn't like what you do, whatever reason. So you get stuck, post it, and it's likely somebody else dealt with that problem. So it's easier to get attention when you post it there. If it is any personal or private personal matters, use emails. And in the professor section or forum, don't post programming type of questions. The programming type of questions are syntax or software issues are in the TA, in the professor for like logic, concept, algorithm type questions. And but don't put anything about grading. If you have issue with grading and the way you're assessed or assessed, that it's appropriate to use email. And the expectation, the university has a policy that you will get response within 24 hours. And as for grading, the requirement is we have to provide grading for each module by the end of the week. So if you submit this Sunday, then you will expect by the next Sunday the grading for assignment. There will be lapses here and there, but for the most part, we will stick with the requirement from the university. Right. This is a, I guess to tell there is a variation of this picture, but the point is data science is unique in the sense that you need multiple domain knowledge or skills across multiple domains. Now, what a data scientist is different from a classical statistician in the sense that it's not just the underlying mathematics. That's not sufficient. So you have to have, and always you practice data science, and I benefited from this. Actually, I happened to start my data science career in a domain that I was familiar. So it was easier for me to transition to a data science as a data scientist because that is expected. You remember earlier the Chris uh, the model assumes that you spend some time in business understanding. That's what the domain knowledge is. You have to, because whether your assumption is valid for that algorithm is also a function of what is expected of that model. Okay. Sometimes you come up with a model, and output that is significant, but somebody can explain the operation. It's a normal thing. The mathematics can pick it. So the point is, you have to have at least a working knowledge in the domain that you practice the data science. And obviously the computer science part, which is a programming aspect, is also very important. And the reason is there are tools. There are, SAS, SPSS, there are rapid miners. These are user interface tools that do not require uh, any coding. But believe me, as you progress in your career as a data scientist, you get to the point you want to do prototypes, quick, quick prototype, quick tests. So for those kind of things, you have to have some knowledge in programming, putting some algorithms, some functions together. You don't have to be a software engineer, uh, but you have to have a working knowledge of programming. So that is what is data science. That's coming out right here right in B2, where you know some mathematics, you have to know some programming, and you have to know domain expert. And usually it's hard to find a good data science because of this challenge. And hopefully, most of you, this is being a graduate courses, you're already working in some domain, so you have some domain expertise in that. Like I said, it's just a working knowledge to make appropriate assumption. But you get, let's say you join a completely new field, and you tend to work with somebody when the domain is considered domain expert. So long as you can communicate with that person, that communication is another critical component of data science. I guess communication is critical for everything you do in life. But so data science is unique in that instance. You're expected to know at least the mathematics, programming, and some domain. Okay. Right. Unless Ashraf has another thing, this will be it, and then we will be glad to answer any question you might have at this point. You can unmute yourself.
Thank you, Fadlu. I think it's a good time to clarify and answer questions if there are any. Please go ahead, everybody. Any questions on the course?
I also opened the chat window, so I'm looking at it. If your mic doesn't work or for some reason and you don't want to speak but type, I'm looking at the window, just send your chat. But any question around this course, any expectation, please. Okay. I guess I don't see any question, and
in the chat.
I'm taking that as everything we said clear enough.
Also, we're gonna post the recording probably also.
Yeah, we will. This section, I hope I'm recording it.
I hope it went well. Yep, recording.
Yeah, and then we will post it in class. You'll have a link for playback.
At the very beginning of the class, it's difficult to even know what question to ask yet.
That is correct. I'm not suggesting that any technical question about, but the parameters, and then you don't have to ask. You don't have to ask. You just.
Well, it was outlined very well in your slides too, so I appreciated that.
That's good. Good to know. But you get a lot of opportunity to ask questions. Believe me, there are some. This course. I'm not exaggerating. You will spend a lot of time working on the time management piece is really critical. We're here to help, but you have to write a report. For you to be able to write a report, you have to fit a model. To fit a model, you have to have understanding, so you have to do exercises. So if you manage your time properly, I think we have good content in the course, good guidelines, and you'll be fine. And that's it. At the end of the course, you will enjoy it. There's good content in this course.
Maybe at this time I can add a couple of things here. If you are in those sections where John is the TA, he posted a kind of helpful announcement, which is, don't be afraid or don't be shy Googling many of the questions that you have, you will find very good and very current answers. And there is a good way and right way, efficient way to, type in search terms. And there are other ways which you will find, a lot of answers, but many of them won't be good. So I think if you could, learn that skill, that's a good skill, and experienced programmers tend to use that as well. Another thing, one particular site I like to visit once in a while, which is called kdnuggets.com. You guys heard about that or been there? Anyone of you guys? They have good articles, and they also have kind of polls on various technologies and trends in this field. So again, the site is KD Nuggets. KD for, I believe is for knowledge discovery. Nuggets, probably referring to gold nuggets from data mining. But anyway, kdnuggets.com. That's a good site to check out what's going on in the field. All right. Maybe there are other sites as well. For any you recommend?
Right. So here's a comment from our TA. Practice makes perfect when writing Google queries. Yeah, correct. Practice.
Yep.
And that cannot be more true in data science. I mean,
Yep.
I can't tell you this. I mean, this is what I do for a living. I work on data every day, and you just learn
that's
everything.
a skill.
Every
Google
day.
queries. Google queries is a skill itself.
Yeah. So if you don't have any questions, please try to attend the TA session Friday. They will cover materials from R, the basics, how you run functions, how you diagnose your commands. So follow that. But if you, for some reason, you can't attend it, we will post the recording from there as well. Okay. Unless you have anything, we call it a night.
I believe Ed is here. Ed, if you have anything to add.
Yeah.
Hi, Ashraf and Ferdu. Thank you very much for your presentation. The only thing I'll add is just I've noticed, sometimes students forget to do some of the simple things like answer the, some of the discussions and things like that, and those are some of the easiest points, So if you can, try to do all the other things because that will help out your grade.
Great. Yeah, good point. Thank you. Yep.
Thanks, Ed. All right. Good night, everybody. Again, we will post the recording tomorrow whenever Lena comes back. And see you in class. Thank you very much.
Thanks, Al. Thanks, everyone.
Thank you. Thanks, everyone.